Okay, today I want to look at a residual plot. Now, before we get started, I want to just talk about what it is that we're trying to do. Here's a model of what we think relationship is between x and y, the two variables. You'll notice that we have a normal distribution, mainly the y normal distribution. This is the entire distribution of y. But when I introduce the variable x along with the variable y, for every value of x, there is a particular y association that is just for this value of x. It is also normally distributed, but the idea being that the variation for the y's for this particular value of x or associated with this particular value of x is smaller than for the original. So now, what happens if I were to sample from a population that actually look like this, where everything's normally distributed? So now we begin to sample. And what would be the probability of landing to the left of the right, to the right of the least squares regression line? Well, you can see that there's a 50-50 chance since the distribution is normal. So you're looking at what would happen right now if I sampled randomly from such a distribution. About half the time you would land on one side, about half the time you would land in another side. But when you get to it, this is what it would look like. You would really know that it came from a straight line, and it's our job to figure out that it does come from a model that has a linear trend. Now imagine that I'm going to take this and I'm about to start twisting it so we can look at it from a top view. So now we get this plot right here, and what is that we're going to do? Something very similar to what you've done before. The line itself here now is just the regression line that we calculate from the data, which is not the actual line, the true line. It's just an estimate of the true line. The red dot you see there is the predicted y value. The error, which was the observed y minus the predicted y, now becomes the residual. I could spend some time explaining why there's a name difference, but one thing I will say is that the intent here is different. So the name changes. Still the same calculation. Residual is really the same thing as the error. Observed y minus predicted y. What happens and what are we going to do? We're about to plot the x value versus the residual value. What will be the result of doing this? Here is what it will look like. This same data set. And this is the result. What used to be the least squares regression line now has turned into this horizontal line right here. The vertical axis, which used to be the y variable, no longer is a y variable. It's the residual. The observed minus the predicted equals the residual. So for every x value from our data set, we'll measure a residual value. What is that we're supposed to see? Well, what I want to see is merely that the dots line up on either side of this line in a random fashion. Again, I have to believe that indeed it came from something that looked like a normal distribution. So half the time they should be above, half the time they should be below, with no apparent pattern except that it will come from a normal distribution. Again, most of the points should be very close to that line. Suppose instead the residual plot had looked like this. You'll notice that this is kind of strange. Look at the way this ordered pairs are lined up with respect to that line. All of a sudden, we would see that it doesn't seem like this could possibly be generated from a distribution that's supposed to be normal. In other words, the line is the center. Half the points should be below the line, half the points should be above the line. But when I look at this, it doesn't seem to match that pattern. So this would let me know that maybe a linear model is not a good model.